evening, everybody. Tonight we've got quite the group from the PyData Calgary, as well as PyYYC, and last but definitely not least, EdmontonPy. My name is Aaron. I'm one of the organizers from EdmontonPy, and typically in our meetups we start with some news and articles, and then we go into the presentation. So with that, I will share my screen. And yeah, sure, we could do that. Okay, perfect. If I have been asked before if you can like zoom into the screen and whatnot. Basically, on the top right corner, there's a of this like screen share. There's a full screen button. You can also hide the right hand panel as well by clicking the arrow that points to the right, and that will kind of give you a little bit more screen space as well. So with that, the PyData Calgary meetup link is there, as well as a link to their YYC, Data Society website. And on top of that, oops, I hope I'm still sharing the screen. Yes, I am. Top of that, we've got PyYYC's website. They have their videos going back to on YouTube and on their website going back to 2012. So definitely take a look at that. And EdmontonPy, we're on the internet. We're also on Slack, and we also upload to YouTube. So yes, this video is being recorded, and we try to get the YouTube links up within a week. So while we are unable to meet in person, I still wanted to thank Startup Edmonton, because without their support, we would not have this remote virtual way of being able to meet together. So thank you, Startup. And as well, I just kind of confirmed with the other organizers that we have a couple 1-year licenses to give away after our main presentation. So if these two icons are not familiar to you, JetBrains is the company that makes a lot of different IDEs, your code editors, and one of the favorites in the Python community is definitely PyCharm. So we're giving out a couple licenses at the end of the night tonight. All you'll have to provide is your email address. You can provide that to me in private, and we'll send you the license through the email. And of course, we're still in it, so keep yourselves up to date with everything that's been going on. These are the links. I will also be sharing the links to the slides here as well once I'm kind of done going through them. In terms of local jobs here in Alberta, I've got one here from Levin. They're looking for a senior software developer. They build kind of more Internet of Things and smart home embedded systems. If that kind of sounds up your alley, definitely. After I share the slides, take a look at their job posting. They are based in Edmonton. Now, Viewpoint Investment Partners, that's actually a company that Ben represents, so I'll give him the floor here.
Yeah, thanks, Aaron. So Viewpoint Investment Partners, we're actually, I actually did it properly. We're actually hiring for 3 roles right now. We're hiring a data scientist, an ML engineer, and a front-end developer. And, we're one of the only quantitative investment management companies in Calgary. So if you think that you want to take some of your technical skills to try and, tame some of the chaos of financial markets, definitely come check us out or reach out to me directly over LinkedIn or any of the various Slack channels. And yeah, I'd love to hear from you. Thanks.
Perfect. Thanks, Ben. And on the Dev Edmonton Slack, we've also got an opportunities channel as well. So if you're either looking for a job or looking to hire great people, that's another place to take a look at. Of course, I think there's also needs to be a slide for remote jobs. That's just become the new reality, it seems. And we've got 2. One is, several, I guess. 2 companies, though, Muckrack and CodeCov. They're both looking for someone with like a Django Python background for either of those positions. Muckrack, they build a SaaS platform for journalists and like news companies to manage their their content and their articles and whatnot. CodeCov, I had to summarize them as a DevOps platform. I definitely looked at CodeCov when I was looking into my CI/CD tooling, and we have people here in Alberta who work fully remote for these companies. So that's why I kind of gave them a special shout out. We definitely have some local people here that can answer your questions. Um, as well, there's also 3 websites I wanted to raise. Again, I will share the slides after this presentation. You can feel free to click them, and they will have job postings that are from companies that are explicitly hiring for remote talent. In terms of events, they are happening. In early December, there will be FlaskCon 2021. That one they are still doing fully online. And I talked to the other former EdmontonPy organizer, I suppose, and she confirmed Pi Cascades will be happening in February of next year. There are a couple more international events as well. Feel free to check them out at python.org/events. In terms of news and articles, 3.9.9 was released, and it was released because there's actually a pretty important argparse hotfix for that. That being said, 3.9 is not the latest version of Python. That would be 3.10. That being said, I know that some places you are still locked down to an older version. So make sure if you're on 3.9, get 3.9.8. Otherwise, if you have any command line tools that were written in Python, they might just not work on something older than 3.9.9. As well, Django's 4.0 release is now in release candidate 1. So it was a beta last month, but this time around it's in RC1. So again, just to repeat for the people who are new this month, with Django 4, it uses a standard time zone library called Zone Info, which is now part of the part of Python when you just download Python and you install on your computer. So that is now becoming the official time zone library of choice for Django instead of PyTZ. And as well, they want to make the default setting of use TZ to now be true, because we have all learned now that you probably want to handle your time zones correctly. And oh, that's right. In Django 3 land, I believe Python 3.10 support is now official. So while Python 3.10 came out last month, the popular libraries sometimes take a little bit of time to officially support them. But I'm glad to say that Django, one of the popular web frameworks in Python, the version 3 now supports Python 3.10. Now, in terms of podcasts, one that I enjoyed was Talk Python number 399. So that one is highlighting how in some of the more recent minor releases of Python 3, there has been a semi-focus on enhancing the performance of Python. So who better to talk to than kind of the original, the OG, I call him, Guido van Rossum, as well as Mark, who is someone who's been working in Python for over 15 years and is someone who's actively working on speeding up Python. And kind of on a fun note, you can also, in Python, represent emoji in using the official emoji name in squiggly brackets. So, I hope no one ever, writes all their code in emojis. Today, I still haven't seen any emojis in my code, but who knows? Maybe that'll become the way of the future or something at some point. So the Python tip of the month is something that I actually kind of learned about yesterday. And it's something that I actually find a lot of, I think I'm going to find a lot of good uses for it. So what are protocols? Well, with Python 3 and with the typing module, you can add what are called like type hints to Python. So Python is known as a duck typing scripting language where variables don't have to always just hold a string. They can hold different things at different times. But that's not in a bigger project, sometimes it's good to have type hints so that other developers can read your code and be like, oh, okay, this is, they know what to expect if you can type in more of your Python code. While using protocols, you can also, with your type hints, remove very long, unwieldy, unions of multiple different classes, and instead make each of your classes implement a protocol. So then this way, in the difference that is shown on the screen right now, instead of having a long sprawling list of union, list, blah, blah, blah for the measurements argument, you can instead define a protocol class called measurement like, because this function really only cares about accessing the timestamp of a measurement like object. So we can define that as a measurement like protocol and basically type hint our calculate windowed average function to say we accept a list of measurement objects that are measurement like, but they don't necessarily have to be specifically temperature, humidity. There could be several other measurement classes down the road. So instead of having to create long 6 element list of unions, let's just create a protocol, and then that way this function can have static type analyses telling you, hey, you're accessing this timestamp here. Yep, that's okay because this is a measurement like object with a timestamp property on it. And this is all a lot more readable than doing it the old way. So yeah, protocols are kind of cool. If you don't need your abstract base classes or mixin classes aren't needed, maybe take a look at protocols. They might help make your code cleaner, but also more readable to your other colleagues. Of course, tonight's talk is titled Data Science as a Platform, DeepSea Analytics, and it'll be presented by Peter from White Whale. Feel free to post your questions in Remo, but in order to allow the presentation to kind of move a little bit more smoothly, we try to answer the questions at the end of the presentation. So, we haven't forgotten you. If the presenter doesn't answer your question, we just we'll collect the questions and then I'll do my best to repeat them at the end of the presentation. And then, yeah, that way we'll allow the presenter to continue, continue on with their main presentation. So with that, I will let Peter kind of take over from here.
All right. How do I do this? Share screen?
Yeah, so there's just a little, oh yeah, there you got it. All right, I'll leave you to it.
Live?
Yes, you are.
Awesome. Thank you. Thanks, Aaron. And thanks, everybody, for joining us in this evening. We have friends all the way from Edmonton, Calgary. I really like this collaborative energy that we have. So what I want to do today is just really 2 points. One is talk a little bit about White Whale and our journey in data science. And second is to do a lot of hands-on stuff, demo. So I think that's what we're all here for. So let's get to that. So White Whale, we are a small data science company solving some pretty big problems. And I think as a lot of us are aware in this industry, we get to work on a lot of different problems, right? So for White Whale, most of our energy has been spent in the energy space, real estate, community, and pro sports. So I've been with the company since 2015 as a head of algorithms. So in my experience, I got an opportunity to work with various clients, and that has been kind of really interesting. At the same time, we did go through some struggles ourselves in doing this when we work with these bigger projects. So what are those? Well, one of the things we ran into was when we create this awesome data science model, we show it to the clients on our laptop, and they ask, well, now what? Like, what happens from here? So one of our principles in this is that we don't just want to share, we don't just want to show the data science models and all the cool things we found. We actually want to share that with the client so that they can internalize it, embed it into their operations, and then we want to be able to collaborate with them closely, resulting in better solutions. So we ran into some issues there. The second thing is we ran into deployment bottlenecks. So as data scientists, we spend most of the time working on the algorithm and model side of things. But once you have a solution that's kind of ready for prime time, deploying and scaling those models in production was actually really, really difficult. So we had to learn a lot of software development, deployment, DevOps skills just to be able to get a piece of code or a model to run in production in the cloud and scale it for the different clients. And the third thing was our operations became really, really complex. What started as a data science kind of consultancy, we ended up having to hire a lot of software developers and DevOps just to be able to not only build, but maintain those interactive apps once they are in production. So all of this really created, a lot of complexity in our operations, and that led up to rethink, what are we really doing? How can we make this simpler? And if we are struggling with some of the challenges, what can we do to such that we can change that data science experience for all the data scientists and consultancies and in the community. So that's when we thought about what are some of the things we want, how do we want to create that new experience? Well, we start with a design principle, and these are the few key points that really go into almost every aspect of DeepSea. The number one is clarity. We want to have something that indicates when the user does something, they know what they're doing. Second thing is collaboration, just to be able to work closely with a client with interactions and activities in a way that enables us and the clients to build a closer relationship and build better solutions. And number three is simplicity. Whatever we built, it really has to be crystal clear, simple to use. And that's kind of what the blueprint is behind DeepSea. So how does DeepSea work? It has a few components. And the number one thing is the data sets, right? You can't really have data science without data, right? So the number one thing DeepSea does is to be able to connect to various data sets, data lakes, various API endpoints, or wherever else where you get data these days. We're working on some integrations as well on that side. The second thing is the ML models. So what it is you have a piece of code, and we want to make it really easy to get that code into a production environment. And that means we need to support a fully automated data pipeline to be able to deploy the code and the models you have into the cloud and scale it as the use changes. And then the third thing is user input. So it's all good and stuff with just the models, but the model is really a dynamic piece of the puzzle, right? So with the data changes, the model needs to change, as well as the use cases with the different users having different inputs into the models to create different desired outputs, different assumptions, different constraints. So these are the things that really go into that interactive part. You need all three in order to build this, what we consider the next generation of interactive dashboards. So all this is good. Let's look at some examples. So what we're going to do today is to look at a few pre-built examples, as well as getting into a live build. We're going to probably spend most of the time on the live build portion of this presentation. So let me just exit my screen and jump over to DeepSea. Let me know. Well, I guess I don't have feedback here. I'm guessing you can see this.
Good.
Cool. So what we're going to first look at is just, this is the DeepSea. I just logged in and I have some dashboards. Let's take a look at a few of those. The first thing, maybe let's look at the COVID, just because this is something that's really relevant to what's going on in society today. So this data came from Alberta Health Services. It's the same data that they have in this interactive Dash app. But what we did is we took the raw data and reimagined what kind of the insights we could get. So for example, we rebuilt this guy. It shows the active cases in red. When did they become active over the course of entire COVID? So the dashboards are interactive. You probably have, it's not too different from existing tools. What we want to create here is something that's not so intimidating, so that the clients are able to kind of play with it. Data science is supposed to be fun, so we certainly try to do that as part of that experience. So at the top, you have here is filters. You can we're looking at Calgary zone. We could tweak it. We can change and maybe look at Edmonton and Calgary and Edmonton. Just showing some of the data visualization capabilities, all the filters, and that, as well as we have a data set on the vaccination. So again, a different data set, but this is what the same data would look like in DeepSea. So this is something that we built just for fun. The second example I want to get into is the community dashboard. So I know in the data science community, a lot of our work actually uses public data, and often it's very meaningful and worthwhile to integrate this kind of a macro community data with whatever the client has internally to kind of do a comparison and help them figure out, are they hitting the demographics or the markets that is desired. So this data came from the Stats Canada census, and the way we kind of reimagine this experience is for any user to go on this dashboard and look up any postal code they desire. So earlier this year, I moved to T2E from T2R. And the way we would get that insight is you could build a scraper, you could write some code, get that data, compile all of it, and then filter it. But the way we're doing this is you have this input bar, basically the postal code, and you have a run button. So what's happening behind the scene right now is that there's a model, there's a Python function that's taking that input and then calling a function and then calling an API on Stats Canada side, grab that data, we do some sort of processing and bring it back to our database. And the result is shown on the dashboard in various forms of visualization. So you have the age, you have the demographics like the marital status, citizenship, education, and all sorts of. You guys are probably familiar with this data set. It's very, very common and popular. So so that just updated to T2E. And back in school, I used to live in H3A. And you'll see that this is Montreal, and it has a completely different distribution of all of these. So yeah, that's kind of the way we imagine how we could use data science and bring the solution that's really, really built out of public data and make it really accessible to the clients when they're trying to look at, trying to understand that community around them. So what's actually happening behind the scene? Let's look at some code. I think code is the best way to bring that degree of clarity. So the model here is actually called, screen's kind of small. Oh, this, right? Just so that we're not taking this from some database and kind of querying the database. This is what the code looks like. I'm gonna zoom in a bit so we can see it better. This is the core of it. Pretty much all the standard libraries that we are used to, NumPy, Pandas, itertools, that's a good one. And then we have some helper function to get the header. We have sort, we have all sorts of just data cleaning, data preparation. So this is the main one, grab data. And what it does is it puts that PC, which is postal code, in this link, and it makes a call to get this CSV. And then Pandas reads the CSV. I think you just read CSV here. And then it outputs a data frame. And then we do more processing on this data frame to kind of organize data in the way that we we desire. So in this case, I can't scroll to the bottom of the screen. So we kind of do a bit more wrangling here to clean it up and categorize it into these categories and groups that we find useful, and output the data frame as a, output everything as a data frame. So everything you're seeing here is executed live with one of the functions calling Stats Canada, and then bring that data back and put it into DeepSea. So you could probably imagine a lot of use cases where you have API endpoint, but it's not possible to call every single combination of those data combinations, right? So you should call it live rather than just get everything and then filter it. So this saves a lot of compute as well as storage space. So the next example I want to show is we won't spend a lot of time on it. It's actually a public dashboard. So this is something that once started as, it's a fun thing. It's a fun topic for a lot of people at the office with F1. And there was a controversy a few weeks ago regarding one of the races, whether or not someone should, it was regarding if they should have made a pit stop or not. And according to data, yes, you should. So these are the things that we really want to encourage through data. It's kind of our vision to be able to build these dashboards and data tools so that they're accessible by the community, and to be able to generate conversation and dialogues around how we can use data to make informed decisions, as well as to be more aware of what's happening in the community. I won't get into a lot of in the details of this. This is a public dashboard, so you can feel free to kind of play around with it in your time. So in the next one is a oil and gas production forecast. So this is something like, the example we kind of show are fairly simple and straightforward, but can DeepSea handle a bit more complicated, complex solutions? And one of the ones which was one of the latest deployments we have is for CIBC. And what we're doing here is using big data. So we are looking at production data for all of the wells in 2 provinces in BC and Alberta. And what the client is using this for is to be able to make accurate forecasts on the various productions from all the wells. So behind the scene, this is a very complicated data science model. What it has to do is to get the data from it's on the public domain, but there are just tons of it, right? Since the beginning of time, since the time the government started collecting these, we have data on every single well, the completion, everything. So typically this process takes a very long time for the operator or the engineers to, take a look at each well and make a forecast. And then at the end of the day, aggregate all of the forecasts in the wells to be able to make a prediction for what level of production they're expecting in the next 3 months, 6 months, year, 10 years, 40 years. So with that, what we did is we turned that into a product that allows them to do this very quickly. So this is, for example, one of the operators, one of the largest ones in Canada, Tourmaline. And here we're predicting 5,000 days of production. Now, as you guys are aware, a lot of times the data science models require constraints and settings that goes into these models, right? And this is where behind the scene in this, we call it the command panel, the model panel, you have access to various constraint. When I click on it, it zooms out. You have access to various user input. So you can directly change these and get different outputs, right? So in this case, we have a few parameters. These are pretty technical, but the idea is that you're able to have all sorts of inputs going into the model before you hit run. So as an example, so Tourmaline has, I don't know, hundreds, how many wells do they have? In this case, they have 813 active wells. So let's take a look at one of them. So in this case, let's take maybe, I don't know, sure, the first one. And then what we're going to do is to get a forecast for this one well. So we can go to the top, the selector, and we can hit run. So again, behind the scene right now, it's taking that one input or a set of inputs you have, going to the data lake, grabbing the production data for this one well, grabs the user inputs, the constraints and parameters you set, and then apply it to the model, and then make a forecast for this one particular well. So typically, as we understand it, this process takes a really good engineer at least a few hours, if not a full day. So with DeepSea, we kind of reduce that to within kind of that minutes range. So things like this, kind of what we want to do is to be able to show the versatility, the complexity behind this solution that we're building. So for this one well, there's a forecast, but unfortunately it doesn't have all of the data, doesn't have the condensates and the oil production. It's a gas well. So these are things that we can do. And then, for example, if I, instead of 5,000 days, I want 8,000 days of forecast and hit run, it will take that into the inputs and then recalculate the forecast. So someone's asking, does the model use the, I won't get into much of that. Essentially, no, the answer is no. there are kind of base models that we get that helps the algorithm identify the type curves that's fitting for these wells. Cool. Yeah. So with this example, what our team had to solve was quite a few things. One is the complexity of the models behind the scene. This one spans quite a few files, as well as there are I think it's this one. I'll show you the code. I like showing code. You know, with this one particular model, we actually have quite a bit of code and dependency, but our system was really designed to be able to handle those very well. You can see that we have our own dependency. We have it's retrieving from various places, you know, data from various places. We have parallel processing in this just to speed up the performance, as well as some sort of what do you call it, the core data science stuff in the in NumPy, pandas, that sort of things. So let's deploy one of these. What is that experience? So to do that, we'll look at some code. So here we are going to. This is I know, you know, we like simple examples. I think this one's very, very simple. So typically this will be your setup. You have your favorite IDE, and from your favorite IDE, you write your code. Some people like Jupyter notebooks. I personally just prefer the straight up IDE. So this is a very simple example. We're creating, say hello. It takes a name as an argument, defaults it to PyData, and it's going to return a string. And the second function here is just going to return a random value from a column of a data frame. So you know, you would have the input data frame, and it's just going to call sample bracket 1, and then it's going to take the column that you indicated in the function, and it's going to return a value. So this is a very, very simple example. So how do we actually get this into DeepSea, into the cloud, in a production environment, have it scaled horizontally as much as you like? So let's take a look at what it looks like. All you need to do is you're going to go to your folder that contains this file here, and you're going to right click, and you're going to compress. So that's the first step, is to get this compressed file. Compression saves space. Second thing is, well, let's go into, oh, where's my demo environment? Okay. You're going to log into DeepSea, and you are going to click on this brain icon, and it really just represents models. And from there, we're going to upload, add package, and here you can select various versions of Python that you like. We're currently supporting 3.7, 8, and 9, but most of our data scientists use 3.9. And here you can click on choose a file, and you are going to select a file that you just uploaded or compressed and created. This is the Pi meetup. I think it's this one. Oh, no, wrong one. This is really small. I can't see it. Pi meetup. Yeah, so there's the random generator compressed file that we just created, and you're going to hit done. And then for the name, I'm just going to call it PyData, sure, and then create. So what's happening right now is DeepSea is taking that package. It's preparing the environments, creating all sorts of, processing to grab the required packages, dependencies. It's going through the functions that you have, and then creating in the back end a understanding of what's in this package, right? So this takes a few minutes, but whatever that's created, it's a completely isolated environment, which makes it really easy to manage your dependencies and make sure that there's no, whatever that works in your machine is going to work in a cloud the same way, in the exact same way. So there we have it. There's PyData. That took about, I think just under a minute. And what we're going to do next is to create a model from the packages that you just uploaded. So we're going to go to Add Model. We're going to click on Packages and select PyData, which is the package we just uploaded. In the file, there's only one, helloworld.py. We're going to click on that. And then we are going to onboard the say hello example. We'll do the other one as well, but this one's really quick. So once you have that, it figures out that the say hello function takes one input, which is name, and it auto detected that default value is PyData, so it puts it there. So that looks pretty good. And on the right hand side, you have a UI to preview of what the model bar, what that run button is going to look like. So you can change it to say hi, and as a in terms of what I want to show, I think I want to show it here in this bar, and behind the scene, this is for so as data scientists, often we have a lot of complex configurations behind the scene, but we don't really, they're not really user friendly. So you have the option of choosing to hide those. In this case, I think we want to show it in this. Similarly, you can also put in the advanced section. So it's now going to this section of the tab for features that you don't see changing often. So you want to get away with that clutter and truly make it simple for the users. So in this case, we're just going to keep both. And we are going to hit continue, go on to the next step. So now that this is all configured, I can hit, well, Ben sent me the invite. So I'm going to say hello to Ben and hit run. So the first time it's going to, takes a little bit of setup. Well, that was pretty fast. So what it does is it creates kind of the backend data set as well as the infrastructure required to receive that data in the future. So now we're done. We have the results and we can hit done. So then how do we then, what do you do from there? Well, often what we find is that you want to be able to visualize the outputs from a model. So here I'm going to create a dashboard called PyData and hit create. Maybe some descriptions for demo. And we have this dashboard. And once we go in there, it's just a blank page. And we're going to add our first visualization, which is going to be a KPI. Basically, we're going to display the text, right? So in this case, we're going to take the say hello output, which is just a data frame. And then we're going to drag the results here and hit save. And voila. So this is our first application. This is now living in the cloud, in production, auto scaling, all that fun stuff that data scientists wouldn't, well, maybe some of us do like spending time on. I'm gonna give a shout out to Edmonton, say hi, and we're gonna see the dashboard. Oh, I misspelled it. Edmonton. Okay, here we go. There we go. This is now an interactive dashboard, live in the cloud. Cool. The next example we're going to do is slightly more complex. So I'm going to go slightly faster as well. So we're going to add a model from the same place, same package that we uploaded, PyData. And what it's going to do, it's going to take a random value from a data frame. So in this case, it's DeepSea is detecting that, hey, you didn't have any default values, right? So if we look at the code, it's just input data frame and column. So in this case, what we really want to do is go in and configure what all the inputs are. So input data frame, we know that the parameter is going to be, a data frame. At the same time, DeepSea supports all sorts of Python inputs. So Boolean, integer, float, string, date, dictionary, list, all that stuff. So in this case, it's a data frame we're going to put into it. And then with data frame, what we're going to do is, we want to show this. We're going to make this visible. The default value is going to take, let's say, I don't know, I have one, cars. Cars, I think most of us have seen this at some point. If not, it's a data set that contains a lot of information about cars. And then in the column, we're just going to put a string. And then I believe one of the column name is identification ID, something like that. Let's see if this works. And by the way, you can see the code here. This is exactly what we uploaded, hello world, and return a random value from a column. And then we're going to hit continue and run the model. So in this case, it just returns a random car from the data frame. So this is kind of showing the purpose of this is really showing that you can connect this to the data frames and data sets that you've uploaded or come from some other place and be able to integrate with the function that you are executing. So, so that's that. Cool. So this is all good, but how does this really help data scientists, right? How does this really help people in our community to scale the solutions or bring this solution into a production environment? So what I did was I was looking at for sample code, and I'm gonna thank Jay from the last meetup for this, that he actually did a lot of good work and published, the notebook containing the telco example. So what I'm gonna do now is to show you what that telco example would look like in DeepSea, right? So we have some data. This is just common data visualization stuff. If you're familiar, what the model does is it looks at various attributes of customers, and then what they're doing is to look at whether a customer will churn, the probability that a customer will churn, yes or no, and that sort of things. So Jay did a lot of good work, and I will kind of reference that code here. I'm just gonna open it here. So what I did here is just copy and pasted the code from the Python notebook, the Jupyter notebook that he had. And I made some modifications, just very small ones, to make it a little bit more scalable and reusable, modular. So on the left, you have the original code that you guys are all writing in Jupyter Notebook. On the right, what I did is I put things in functions, and I commented out a lot of the code because we didn't really require them in DeepSea for production. And then we have the three models where the LR_best was the best one. And then I wrote this one function here, and what it does is it predict customer churn probability, right? And instead of looking at one model, typically a good practice is to get an ensemble or predictions from multiple models and use that as a better way or more robust way of determining something. I also have this. This is also in the notebook, but we aren't using this. You could, but just not for this application that I am building. So on the left, again, you have the code that was in a notebook. And on the right, you have the code that's kind of tailored a little bit just to make it a bit more modularized and production ready. So I'll show you that code in production. So you have the telco model. Where is that? It is here. You can see the same code that I uploaded here. Let's preview. Oh, whoops! I didn't click on the code. So this is the same code that I'm showing you in the notebook, in the IDE. And what we're doing now is to look at, what kind of solutions, just from that Jupyter notebook, how do you turn it into a product and put it in the hands of your clients? So this is the customer churn dashboard. What it does is it takes a user ID, in this case, this user here, just a customer ID, and it displays some, common attributes, monthly charges, total charges, a little bit of the customer themselves, whether they have, what kind of payment methods they have. Well, this person has mailed check and not a senior. Huh. Okay. Yeah, and overall you have a churn probability of 38%. So there's a a pie chart showing that, and these are the results from various models. So let's run an actual example. So let's go back to the data and grab a customer. I'm going to click on this, grab a customer ID, and we are going to input that ID into the function, into the command bar, and then look at what the probability is that they will churn, maybe this person, or I don't know. Let's try one that's further down. This person. And we will run it here. Hit run. So right now what's happening again is it's taking the data from with this customer ID. Once it has that data, it's going to take that row of data, perform feature engineering, do all sorts of data preparation, and then run it against the 3 models that we have built in that code. And then it's going to output the results into a data frame, and then have the results displayed on the dashboard. Sorry, comments there, Ben. Sorry, I don't mean to be judgmental there. It's just, I did look around this data set quite a bit, and in building when it comes to building the models, these are important features that the model considers. Okay, cool. So for this person, 0076, there's a probability of churning 26%. So if you are a customer service representative and you have this person calling you, you are looking at a 26%, and you know that these are the services they have, and kind of give you a better understanding of the customer so that you can provide a better service. So we have actually seen lots and lots of this kind of application in our clients as a way of identifying how do they ways to create a better connection and engagement with their clients. Cool. So yeah, that is how we turn a notebook into a product. So at this point, I think, yeah, let's take some questions.
Sure. I think you answered a lot of the questions as you were presenting, so thank you for that. The one question though from Daniela was, can you share the link for the Wells dashboard at all?
Oh, that is a tricky one. We may have to connect offline on that, just
Sure.
because those are not public. We deploy those for specific clients. Yeah.
Cool.
Let's connect offline though.
Yeah, that's cool. Yeah. I'll let Daniela kind of handle that. But okay, sounds good. Then we have this follow-up question here. Can you speak more on the unique value proposition for DeepSea? Here's your Dragon's Den stage rehearsal, I guess.
Yeah, so what we see in DeepSea is a way for data scientists to take their code into production with minimum rework. So there's a lot of complexity that comes with scaling and maintaining a full solution in the cloud. But with DeepSea, you really focus on the things that you really, your expertise in data science in that Python world.
Oh yeah, there was. I was going to ask that question. But Lita asked, does that have Python?
So yeah, we started with Python just because we are drawn to the community, the open source community in Python. But certainly in the future, we're looking to support R. That's another one that's fairly common in the data science community. So we're looking to do that. Yeah. And do we use any? No, sorry.
Oh yeah, I guess yeah. I typically like to do the asking of the questions.
Yeah, go ahead.
I think you've talked enough. You've talked enough for the whole night. But yeah, Brian is asking, do you use any third-party cloud platform or tools such as Azure, AWS, etc.?
Yeah, so DeepSea is deploying in AWS, but we stick to the more basic offerings AWS has. So that's EC2. We do use ECS and S3, but we couldn't really see, how Lambda could have helped. We don't use SageMaker. I know I'm speaking for AWS, but similar kind of machine learning services in all the major platform, we actually we did explore, but it was not appropriate.
I did notice that kind of building off on Brian's question that and you're talking about how like most of your tooling as well is about kind of open source. So I guess it, with that mentality, it probably lends itself better to kind of stick with just your what instead of having to adopt like a locked in vendor's machine learning solution.
For sure. So for us, if this helps at all, DeepSea runs locally on your machine. You can run the entire DeepSea application in Docker containers.
Oh, I was going to ask. That was going to be my next question. Is it in Docker? Yeah. But okay.
Well, that's a good one. I personally am a huge fan of Docker, and I really encourage even if you're a data scientist, look into Docker. It may really help with some of the work you're doing in making the environments and the entire container consistent. I don't know if there are other language to describe that. It kind of took it.
Mm-hmm. And so, yeah, it looks like we've got now we're getting a lot of questions. Okay, this is great. So one at a time here. I guess Leslie's is next. So our Python extensions, do they seem to update frequently enough? Or are Python extensions getting updated frequently enough to not impede on, developing your product? And do you have any sort of extensions that have been developed as part of DeepSea?
So these are the things that we have not really, we use a lot of the tools internally, but we have not released any on that regards. But certainly we have gathered a lot of interest in kind of just using the DeepSea function, serverless function aspect of DeepSea. So yeah, it could be something we look into in the future as a standalone service that we would offer, just to run your functions without the visualization, no dashboard, no logins, that sort of use cases.
Okay, I'm gonna switch over to the Q&A tab here because even I don't use the Q&A tab, even though I'm a remote organizer. But yeah, it looks like Jennifer, you figured it out. You're using software the right way, the way it was intended. But yeah, her question, she has too. Are you using open source machine learning model libraries like scikit-learn, or is it something custom or proprietary?
Yeah, so we didn't show this. We could, but basically in the code, in the package you upload, DeepSea actually goes through all of the imports and dependencies. So it depends on which ones you use in your code. That's what DeepSea deploys. So there's no really magic in the sense that there's built-in, machine learning services that do these predictive things for you. You do have to supply that code. What DeepSea does do is allows you to be able to indicate the packages you're using. In the cases you don't indicate, it will automatically detect so that there are no conflicts, right? So there was one case where you guys probably well known is Python 3.9 doesn't work well with Pandas 1.0, which had been stuck on Python 3.7. So things like that, DeepSea will figure out to cause the least amount of dependency-related issues in production.
Sounds good. Okay. And then her second question was, in the customer churn example that you showed, do you have a prediction accuracy metric?
I'm going to defer that to Jay. We actually went pretty extensively into showing the accuracy, the F1, all the good stuff, the technical stuff. So yeah, it is possible.
Okay, wonderful. And now I'm going to switch back to the chat tab here. So Jay himself has asked, are you using any analytics tool for the dashboard? I guess the question, I'm not, but yeah, not quite sure.
I'm not sure. I'm not sure what is meant by analytics tools. Maybe
the front end like
The front
libraries or
end.
like the tooling, like what how was the front end built? Although that could kind of,
Yeah.
you don't have to go too much into
Well,
that, but
typically I would defer this to my development leads on this. They know they're just know way much more about software development. But I think there are visualization packages that we use for that, but most are in the open source community.
perfect. And so Constantine here is asking, can you please tell us more about which data sources are supported and how they are integrated?
Yeah, so our design principle on that is to be able to work off of however data scientists work with data sources today. So the ones that we do support currently are CSV uploads. That's a very common one. And the second are the data lakes, specifically AWS S3. In the upcoming year, we do have a roadmap on more database integrations. Currently, we have, so DeepSea is compatible with things like Salesforce, just because that's one of our customer, they rely on Salesforce as their backend. But the design principle here is to really work with whatever data scientists are familiar with. So we'll continue down that path.
Right on. Okay. Yeah, I mean, CSVs are like a lot of other tools do export to CSV as well. So, that at least that's covered. But yeah, part of the roadmap as is natural. Sarah here then asks, you mentioned that white whale has been used in energy, real estate, sports, and community engagement industries. Are these the industries you expected white whale to appeal to, or are there any industries not mentioned that you think this would be particularly useful for?
Yeah, so to answer that, I think we have to stick to our core beliefs in the data science as a way of thinking and problem solving. So I think, like a lot of us, we are pretty industry agnostic. I think being Calgary, it does help us with being so close to a lot of the energy producers, as well as things like the pro sports with Calgary Flames. We work with them closely because the proximity in the city. But certainly, I think as soon as you get out of Alberta, there are other industries in finance, in healthcare, all that good stuff. So we really want to design DeepSea to be industry agnostic, such that data scientists could take this and express their own creativity and expertise in deploying and building their solutions.
Right on. Okay. And I think we're going to wrap up the questions here. But again, the lobby will be open until about 8:30. But Abhishek asks the question.
More? Okay.
Yeah, we got one more. And he's asking, how are you securing customer data?
Yeah, so that's a really good question. So right now we are looking at having the customer take on the burden of securing the data. So usually it's an access point that they provide us to access their data lake, or in the cases when they don't have a data lake, we put their data in the data lake. They ship that data to that data lake, and we have we then query or pull the data from there. Obviously, with data and privacy ownership, it is a sensitive topic. A lot of it is going to be case by case in working out the kinks with the legal. In the other space is working with the public data, which makes it a lot, have a little bit more flexible there.
I see. Okay.
So I thought I would close. Sorry, are there more questions?
No, you have the floor.
Okay, so I thought I would close out with kind of what did this mean for white whale? So in 2015, we worked with some pretty big clients. And it was the first real taste in data science for a little company. And this is typically what our engagement looks like. We have about 3 weeks. We spend about 3 weeks in building a paper solution that kind of tells the, that kind of builds some sort of line of sight to how we can use data science and algorithms to solve a particular business problem. We start coding about week number 3 to get some stuff working, to be able to kind of show it with the clients and go over some of the results. And then around week number 4, we started building the backend, and simultaneously look at the front end designs, the dashboards, or some sort of user interface and interactions, inputs, that sort of things. And that's essentially majority of the software development time we spend. And typically it takes up to just over 2 months. And over that time, often the data science team has to rewrite some of the code in order to be compatible with a back end and front end systems. At about week number 10, we start to look at the DevOps side of things to get those models and the software itself, the entire application, into the cloud and start to look at the DevOps and the scaling side of things, right? So a lot of that we do reuse, but it becomes really repetitive. And when there are some changes, we have to go through every single application to do that. And that becomes really, really time consuming and costly. So that was us in 2015, which, 16 weeks for an application, it wasn't bad, but we were certainly struggling with just keeping up to speed. So with DeepSea, what we're finding is that we are taking away all that time with the back and front end and the deployment, right? And have that code from week 3 work in production. So that's the benefit that we're seeing. And we hope that with DeepSea, we can really scale that to all the data scientists who are looking to not just have a prototype or a demo, but have a full out production solution that they can then monetize in the real world with the clients. And to close up, we do want to hear from you. So there is a door prize for filling out the survey. It's gift cards to a food delivery service. So that's going to be on us. You can scan the QR code or take the link. I don't know if I can copy and paste in chat. There we go. I'll just paste in chat. We do want to hear from you because one of the things we truly believe in is just the power of a community with data science. We want to be building relevant features in terms of doing things that's actually meaningful and useful for the data scientists. So take a minute to fill this out. We do want to hear from you, and if you're interested as well, we can have a deeper level of engagement when it comes to DeepSea users and all of that. So please fill it out if you can. We will do a draw for a door prize and probably just give people a few minutes to do that. And while the responses are coming in, I am going to set up a open source way of making that draw. So if you recall earlier, we made a random value generator. So what we're going to do is to take the data from the survey, which is also in DeepSea form, So this is DeepSea forms. So this is that PyData. These are the questions. So the data is going to DeepSea, and what we're going to do is make a random draw from the responses. And yeah, the lucky person will be getting a gift card. I'm just gonna, in the meanwhile, set up some. I'm just gonna set up a interface to show that.
Perfect. And while you're setting this up, looks like we're going to be giving out a couple things tonight. So on top of the White Whale store prize, there's also going to be some PyCharm licenses that we want to be doing a draw for as well. I don't have anything as fancy as a DeepSea random, draw offering, but I have a little something else as well. So yeah, for all those that stick around till the very end. Yeah, okay. I'll let you kind of continue doing this, and I too will also fill out this form. Or actually, you know what? Let's make this a bit more efficient. Peter, as you're developing this, how about I start gathering some names for the PyCharm draw itself. So for those in the room, if you would like to be added to the PyCharm draw, I guess I should put up my screen this time. Replace. Why does that not work? There we go. Yeah, if you'd like, just kind of just type in PyCharm in the chat, and I will add your name into the PyCharm draw. Feel free to do this until we are out of presentation mode. This way I know who is interested. Sounds like based on the other organizers, we may have more than one license to give away this time. If you are drawn as the winner, all we do is we ask the winner to provide an email. So yeah, just kind of once your name is thrown in there. I don't have anything as fancy as Peter's dashboard, so I
I'm
had
just
to,
having a bit of fun here.
yeah, no, I just had to let's see, I think my screen's still being shared. Perfect. Created myself in replit.com, which I didn't mention last month, but it's also a nice way to just have like a development machine without needing to have a physical computer. So yeah, keep typing in the PyCharms because essentially I will just be adding your names to this draw. Oops. Oh. Okay.
I think we'll be closing in shortly.
Yeah,
If
this
people
event
wanna
will
just-
wrap up at 8:30. So Peter, just let me know. Are you ready to do the door prize draw?
Yeah. Let's see. Are there people who needs a couple more minutes? Well, why don't we close it off in 30 seconds?
Sure. Yeah, we'll close off the door prize from White Whale, and I'll just post that link again. You've got, we'll say until we'll say 8. Yeah, we'll give them about a minute or so, and then I'll let you kind of do the drawing. I have taken, I think both our screens are being shown, but I've kind of taken over the main section just for a bit. Just gonna continue adding the names as I see them. Oh, I totally had a moment there, and instead of copying the person's name, I copied PyCharm like their message. Congratulations, PyCharm, on winning a PyCharm license. No. Okay, I think I see 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so I've got about 9 people have thrown their names into the hat here. So reading my own trusty README file, because I have to admit I forget how my code runs after like a month of not looking at it. So and in I guess if people want to believe me, I did cover the little Python script. It's essentially just using the random module in Python, using the sample function, which by the way is super cool. If someone has won and you're trying to draw from multiple people, Zample just takes the person who has won previously out of the hat, and that way you can't draw the same name twice, which is amazing. Python is amazing, but okay, I don't see any new names, so I will run our giveaway finder. And this month, Andrew tells me we have 3 licenses, so please work. It works. Okay, so
Nice.
congratulations, Abhishek, Chris, and I'm gonna pronounce it Anders, but I probably got that wrong. Congratulations to the 3 of you. You can feel free to either message. You can probably private message myself, or even just message gentleman there named Andrew. I think we just have one gentleman tonight named Andrew. Andrew helps out with the PyYYC meetup, so you're not sending an email to some random spam bot. I know this Andrew fellow; he's great. So yeah, either send him the emails, your email, or send me, and we'll make sure that you get your 1-year PyCharm license. Yeah, hooray! Congratulations to the 3 winners. And I will now stop screen share. And Peter, I think I will let you do your draw.
Sure. So this is taking the data from that PyData survey that we send out, and it's going to randomly select a value from question number 1, which is your name. So we're going to hit run, and whoever's name comes up, please message myself. Oh, we have one. Lida.
Perfect. And how would
congratulations.
Right on. How would you like Lita to kind of just communicate through Remo here, and you're good?
Yep. Could Rachel, if you could please reach out to Lita and set that up, please.
Okay.
We'll get that on the way.
Perfect.
Thanks,
Wonderful.
everyone.
Yes, and thank you, Peter, for doing this presentation. There's so much that can go wrong during a demo, and the fact that, like, yeah, it seems like it's either really good rehearsal or really good product, or probably both. I think that was really well done. And
I have to give my shout out to my software development team and operations team on this, as well as data science for preparing all of this. You guys are awesome, so keep it up.
Perfect. And I just have one last screen to share with everyone, and it's basically announcing when is the next time we will all be meeting. We will be taking a break in December. I think we all deserve one. And well, that and the fact that I think a lot of the organizers are either on holidays or, but yeah, we will be meeting in January. I believe I have the date correct. It's always the 4th. Currently, it is always the 4th Wednesday. Yeah, January 26th. Yes. And we are always looking for presenters. So all we ask is that it has to be a talk to do with Python in some way. And yeah, with that, I just want to say thank you to everyone who has stayed around. Abhishek, I will definitely contact you in a little bit here. But yes, thanks everybody. We'll meet up again next year.